we have a ton of divisibility rules. Some you, I'm sure, know already, and some might be new to you. But we're going to look at an example for each and then look at some harder questions to make sure you can answer questions based on these. Okay? So the first thing is simply some notation at the very top here. We use this kind of shorthand to say A divides B. So, for example, 2 line 10 would be 2 divides 10. That's how we read it. Okay? That avoids a lot of writing as we go through these problems. If we put a slash mark through it, that one might not be terribly obvious, but it looks like this. It's the line with like a slash mark through it like that. Okay, that means it does not divide. So we would say, for example, that 3 does not divide 10. Okay? Another thing to be careful about as you read these is that there is a difference between the number and the digit. The digit is just the individual, the number that's in each place value spot. Okay? So 2,347 has 4 digits, 2, 3, 4, and 7. So if I said, what are the last 2 digits, what would that be? 47. And if I said to find the sum of the digits, then we add those digits together. Okay? So there's a big difference between listing the digits, finding the sum of the digits, and just looking at the number. So be careful as you read these rules. It's easy to confuse. So divisibility by 2, if the last number is even, right? We've probably been doing divisibility by 2 since we learned how to multiply by 2, right? So give me an example that is divisible by 2. The number 6, and we could even go bigger and say, well, we're going to put some big examples down. So like 216 is divisible by 2 because we can look at just this last, got to switch to my toolbars again. I don't know why those don't come in standard. Something to look at later. Okay, so if I look at just this last digit, I can tell from that, right? And so a number that would not be divisible by 2 would be like 217 because this is not even. Okay? So divisibility by 3, we have to look at the sum of the digits. And if the sum of the digits is divisible by 3, the original is divisible by 3. This comes in handy when you're doing things like long division and you're trying to figure out, what goes into what. So for example, we'll look at the number 200. You've got one already for me. 216, yes. So if I look at the sum, 2 plus 1 plus 6, we would have 9. And we know that 3 divides 9, so 3 divides 216. Okay. How about, well, an easy way to make something not divisible by 3 would be to write what? 217. If we add these digits, we'd have 2 plus 1 plus 7, which would be 10. And 3 does not divide 10, therefore 3 does not divide 217 either. Okay? Divisibility by 4 is a little bit stranger. Anyone ever seen this one before? All you have to do is look at the last 2 digits. And the last 2 digits tell you whether the number is divisible by 4. So I'm going to give you a fairly big one here. If we look at 4324. Looking at the last 2 digits means I literally just inspect that. And I say 24. Is 24 divisible by 4? Yeah, and so is the original number. Okay? So if I looked at, for example, 4325, and I look at these last 2 digits here, I can look at those and say, well, was 25 divisible by 4? No. So this number isn't either. Okay. I'm going to show you why in a second, but I don't want to break away from this video, go to another video, and come back. So just wait for it. I'll show you why this works. Okay. It's actually really easy to explain why it works. Not as easy to explain why the 3's work, but there's a way to do that as well. Divisibility by 5 is another one you're probably good at because we count by 5s a lot in money problems. And by our hands. So if the last digit is 0 or 5, then the original number is divisible by 5. So you can all think of examples that work here. So for example, 455 would be divisible by 5, and 450, I didn't even write what I said, 458 would not be divisible by 5. And again, we're just looking at this digit now. Right. When we get to 6, we have to break it up and look at it as the factors of 6, the paired factors that make 6. So 6 is 2 times 3, and we know how to check divisibility by 2, and we know how to check divisibility by 3. Okay? So if we look at, for example, 1536, to check divisibility by 2, I just look at the 6, and that's good, right? To check divisibility by 3, I add them all up. So if I add them all up, that would give me 15. And is 15 divisible by 3? Yeah. So is this divisible by 6? Yeah, because it meets both criteria. Okay? What? On this one or this one? First one, yeah. 216 was a very good choice, it turns out. If we look at 1538, it meets one criteria but not both. Which one does it meet? Yeah, which one does it? 2 works, right? 2, it works as a divisor, but not 3. If we add up the digits, we get 6, 9, 17. So if we do 1 plus 5 plus 3 plus 8, we get 17, which is not divisible by 3. If one of them fails, that's it. Not divisible by 6. Okay. For divisibility by 8, let me give you one here, 1328. And it turns out this one's a lot like the 4 rule. We look at the last 3 digits here. So we would look at 328. Unfortunately, this is where you actually will have to do a little bit of division. But if the number is really, really big, it helps to only look at the last 3 digits. Okay? So I have to look at 328, and I have to say, well, does 8 go into 328? So let's see, 8 goes into 32 4 times, and that would all go away. 8 goes into 8 once. So it works. You with me on that? So if it goes into 328, then it also goes into 1328. All right. Example that doesn't work would be 1326, because if we do the division there, putting 8 into 326, 8 goes into 32, and that's just fine. We could do the subtraction, bring down the 6. 8 does not go into 6, so this would be like 40 remainder 6. So if the division doesn't work, then 8 does not go into the entire number. Yes? Yes?
So I could put anything I wanted to in front of 328?
You could put anything you want to in front of 328, and I will show you why that is. Just, wait for it. We got to get through a few more. It's really obvious once you know how it works. Okay? It'll be cool. So 9 is a lot like which one? 3. Does 216 work again? It does? Wow, good choice. All right, so did you plan for this? No, really? Just natural talent? Okay. So 216 works. 2 plus 1 plus 6 would be 9, which is divisible by 9. Okay. And again, 217 would not work, right? Because 217 would be 2 plus 1 plus 7, and that would be 10, which is not divisible by 9. Okay? 216 fails on this one, I'm afraid. 2160, though, that would work, yes? So there's one that's divisible by 10. If we reverse a couple digits here and write 2106, there's one that's not divisible by 10. That's another one we've been working with pretty much our whole life. And then finally, the last one we're going to do here is divisibility by 12. And so 12 is like which one? 6. 12 is it's a composite number, and there's 2 different ways we could make 12. We could make 12 by doing 2 times 6. We could make 12 by doing 3 times 4. The problem with using 2 times 6 is that 2 is already in the 6 rule. So we need 2 rules that are completely different from each other. So we use 3 and 4. And so if we test 3156, so how do we tell if this is divisible by 3? Add them. So 3 plus 1 is 4, plus 5 is 9, plus 6 is 15. So that works. And how do I tell if it's divisible by 4? The last 2 digits. So I look at 56. And if you're not sure, you can always write out the division. Does 4 go into 56? So it goes once here. Subtract the 4. Does it go into 16? Yes. And so it's good. Okay. So let's look at 3152 and see if it fails both or just one of those tests. Is 3 a divisor of 3152? No. Is 4 a divisor of 3152? Yeah, it is. We look at 52 and then the division would work out. Okay. But again, it has to be both. There are 2 other rules that I, just kind of skipped in this table. That is 7s, which is such a heinous rule that you might as well just do the division. Okay? There is a rule, and I encourage you to go look it up on Google because you'll get a kick out of it when you see it, that anybody would use this technique. But anyways, 11s is not as bad, but it's really weird and it's hard to remember. So I'm going to show you one example with 11s, but I'm not going to require that you know this one. Okay? So let me give you a fairly big number. It's actually easier to explain if you use a big number. So we're going to do 7204857. Okay, and so then this is the weird part. You look at the odd numbered digits. So that would be adding 7, 8, 0, and 7. So what do you get with this odd sum? 22. Okay, so that's the yellow sum. And then we're going to do the exact same thing with the even digits. So we're going to go 5 plus 4 plus 2. And what's that one? 11. And then you take the difference between these two. Do it so that the difference is positive. So whichever one you need to put on top, put on top. So you take the difference between these, and the difference is 11. So if we do 22 minus 11. And so then the question is that difference divisible by 11? Is it? Yes. So this number is divisible by 11. It's weird, huh? That one is much more complicated to explain. Okay, but it does work, and it's kind of a nice little parlor trick, Give me any big number, I'll tell you if it's divisible by 11. You impress your friends. No. Not your friends. Okay, maybe your parents. You can impress your parents. Okay, so let me show you now why the 4 and 8 work, because these two are really slick, and they're really easy to explain once you've